Okay, this compound inequality, we first solve each of these linear inequalities separately, and then we figure out what to do with the or. So to begin with, to isolate the x term, we have to take 7 away from both sides of this linear inequality. And at the same time, we might as well add 12 to both sides of this one. That will just leave the 15x on the left of this one, and 3x all by itself here. So we have 3x is bigger than 10 minus 7 is 3. And here we get 15x is less than or equal to 18 plus 12, which is 30. Now to finish solving these inequalities, we divide both sides of this one by 3 to cancel out the coefficient of x. This one we divide both sides by 15 to cancel out the coefficient of x. This results in x being bigger than 1, or x is less than or equal to 2. Now, so we've solved each of these linear inequalities. Or, remember, refers to, in set notation, union, a big U for union, which means we're looking for, to solve this compound inequality, we're looking for all real numbers x that are either bigger than 1 or less than or equal to 2, or possibly if there was one that was both. The easiest way I recommend solving this one is to graph each of those inequalities on number lines that are completely lined up. So the zeros are lined up, the ones, the twos, and a third one for our solution, the union of both of these sets, which is what the or is referring to. So the numbers of importance here are 1 and 2. So I'll make this 1 on all three number lines. There's 1 on this one, there's the number 1 on this number line, and there's the number 1 on that number line. And 2, so I'll make this 2 on all three number lines. The first inequality will graph on the first line, the second inequality will graph on the second line, and then on the third we'll graph the solution to our compound inequality. So the first one, x is bigger than 1. Well, that just means that x lives somewhere to the right of 1 on this number line. That's the first one graphed. X is bigger than 1. X is smaller than or equal to 2. Well, that means it's to the left of 2. Or it could be equal to 2 because this one includes the or equal to part. So there's the arrow going that way. And this time we're filling in the little circle because this one is or equal to 2. Now we're looking for solutions that are in one shaded region or the other. Any x that's in one of the shaded regions or the other. And you'll notice that over here, anything on the second, for the second inequality is true, so it's shaded. So that'll be a solution. Anything in the middle is where both inequalities are satisfied. So if it was an and, the overlap is what we're looking for, just between here and here. But now we're looking for the union, the join of the two. So anything that's in both is considered part of this solution, and anything that's just in the first inequality is considered part of the solution. So the whole number line gets covered here. The solution to this one is all real numbers. Every point on the number line gets shaded. The way we put this in interval notation is to say, because you can imagine there's a negative infinity at the end of the line on that side and a positive infinity on the end of the number line on the other side. So this is the open interval from negative infinity up to infinity. That's how you would graph this. This is all real numbers. Mathematicians have a symbol for all real numbers, which looks like that. In set builder notation, this is equal to the set of all x such that x is between negative infinity and positive infinity.